very, very important to National Grid. It's through forecasting that the operations that we have to run the National Grid most efficiently can be optimised. This project at Sheffield University, the combined approach to wind profile prediction, is a key example of that, because we've brought together researchers from the engineering department and the mathematics department.
In this project, we want to develop a more efficient algorithm to predict wind profile, which is important for predicting wind energy output. So our idea is to combine two traditional methods, signal processing and computational fluid dynamics.
I want to let the National Grid to use one single program directly without any updates and without any errors.
I think with more accurate and faster wind profile prediction, I think National Grid will be able to operate more effectively in the energy market. And certainly this will mean lower cost for National Grid and also lower bill for the UK customers, including us.
The PV industry in the UK has been incentivised by a number of different government schemes, and over the last 5 years there's now a growth from around about 0 systems to about 700,000. So there's been a massive explosion of PV power systems in the UK.
Sheffield Solar is a research project at the University of Sheffield where we're looking into the performance of PV systems around the UK. Where that's applicable to the National Grid is that they're interested in the impact of PV systems at a grid level, and we're able to give them a better estimate.
The challenges with solar is the visibility. There's something like 650,000 sites out there in the UK, and they're all connected at a very low level, so they're below the level of the transmission network, which means National Grid doesn't have direct visibility of them.
And the project that we have will increase renewable energy on the network, so reduce the wholesale cost further, but it will also reduce the cost of controlling the network, so there'll be a double impact on consumer bills.
Using response surfaces enables us to take into account orientation and tilt, as well as the location of the systems in a statistical way. So we're not relying on knowledge of the physical processes underlying the PV generation. Instead, we sample the generation and then take a statistical approach.
We're able to manage the generation portfolio more accurately and run the system at the minimum operational cost.
It's been a very exciting project to work on. It's a new area, a balance between operational results and research.
Even though in this project we aim to predict the energy output, I would say the most enjoyable elements are the unpredictable outcomes.
So as an academic researcher, I really like projects where I have to engage with real-world problems, and problems that have a real impact in the here and now. And I think that's the sort of problem that we're working on here with National Grid.